Okay, so guys, this is going to be the third video for Chapter 9. Section 9.3 is about comparing within subject and between subjects designs. So we have discussed both, and so now we're going to talk about how do you decide which to use. This is going to correspond with learning objectives 6 and 7 from your chapter, which talks about the advantages and disadvantages of a within subjects design versus a between subjects design. And then it's also going to introduce the idea of a matched subjects design that basically kind of tries to combine the benefits of a within subjects and between subjects design. Most questions and hypotheses can be studied with either design, between or within subjects. Sometimes you don't really have a choice, but a lot of times you will. And so it largely depends, which one you choose largely depends on these advantages and disadvantages that we're going to discuss, and which you think affects which will affect your variables more, depending on what you're studying. So the advantages of the within subjects design is that it requires, again, relatively few participants because they're all experiencing all of the treatments, so you need less participants than between subjects. This is especially important if you're studying a group of people that there aren't very many readily available. For example, it said if you're doing a study on 80-year-old twins, it's a very small, narrow population. So you're not going to have that many participants available, right? And then also or if you don't have a lot of resources to recruit a lot of participants, that, is a benefit as well. It also eliminates problems based on individual differences. Again, that is one of the main problems with between subjects design is those individual differences. And so you don't have those because it literally is the same people in both groups. And so there are no individual differences. And then also it reduces the variance. Remember, we talked about how because there is less varying of the scores within each group, because it's the same people, that means it increases the chances of detecting the treatment effect. It increases the chance that you're going to be able to see the actual difference between the means and your effect of your independent variable, if there is one. So within subjects design, this is kind of furthering these advantages. Within subject design has no individual differences between groups, right? There really is literally only one group of participants. So the group in treatment 1 is exactly the same as the group in every other treatment because it's the same people. And so there are no individual differences between the groups that could be a potential confound or a threat to the internal validity. This means that each subject appears in every treatment condition and each subject serves as their own control. And what that means is, if we go over here to this table 9.3 from your chapter, this means that if you see in this first part, A, these are all different people in each in each condition, right? John, Mary, Bill, Kate are in treatment 1. Sue, Tom, Dave, Ann are in treatment 2. Beth, Bob, Don, Zoe are in treatment 3. So they're all different. If we go down here to the within subjects, you see that it's only John, Mary, Bill, and Kate. So again, less participants. There's only 4 participants here. But also you see that each subject serves as their own control. And the idea of that is we're comparing, when we go across here, up here we're comparing John, Mary, Bill, and Kate to Sue, Tom, Dave, and Ann, and then comparing them to Beth, Bob, Don, and Zoe. But down here, we're literally only comparing John to John to John, and Mary to Mary to Mary, and Bill to Bill to Bill, right? Like, we're not comparing John to Mary. Because we're comparing the groups, and the same people are in the same group every time, right? This again eliminates those individual differences. And also, because of this, we can actually see and measure and remove the differences between the participants. So like John, you can see consistently scores lower than everybody else, right? And Kate consistently scores higher than the mean, higher than everybody else. And so they're different people. Right? Their scores are different. We can actually measure this and see this in a within subjects design. If it's consistent, you'll see that it's consistent. Kate's high in every treatment. John's high in every treatment. So if it's a consistent thing across all treatments, you can actually measure that and remove that. Um, and because of that, you're able to see the difference between the groups even more so. We're reducing those individual differences even better. So because of that, um, statistically, we would say that a within subjects experiment or design is more powerful statistically. We are more able to see that difference between the groups than we are with a between subjects design, because it's not, that static is not there, right? We're not, it's not being contaminated. It's not being overshadowed by the individual differences between the participants. And so I want to show you guys, let's see. Oh, so here, so table 9.4 shows where they removed those differences we were just talking about. They were able to measure and remove those individual differences. And so the means actually became, the scores actually became closer to each other, but you'll see the means did not change. The treatment effect is still there. 41, 45, and 49 are the means. And that's the same up here, right? 41, 45, 49. They did not change. The means did not change. And so because of that, you were able to see, and this is showing you graphically how you're able to see the treatment so much better, the treatment effect rather. If you look at the top, this is when they didn't remove those individual differences, and you see, you can't tell if blue is higher, red's higher, orange is higher. It's all over the place. They're all mixed together as far as along that x-axis. It's not clearly orange is always up by 70, and you know they're all mixed together. There's no the pattern red, blue, orange. It's all mixed in there. If you look at the B, the graph in B, where they remove the individual differences, you can see there it is very, very clear. Orange is all at the higher end, blue is in the middle, and red is the lower. So treatment 1 was the least effective, treatment 2 was moderately effective, and treatment 3 was by far the better treatment, the most effective treatment, or had the largest, impact on the dependent variable, right? And so that is a lot easier to see with those individual differences removed. Now, there is also some disadvantages within subjects. We've talked about that kind of already a little bit in this chapter previously. Each participant is going through a series of treatment conditions each time, so that is those time-related factors and those order effects that can influence the subject scores, right? We talked about that a lot. The other thing is participant attrition. Now, this is different than that differential attrition we talked about, where some participants might drop out of one group or the other, and it makes everything unbalanced. This is overall attrition, just participants dropping out of the study in general before it's completed. This obviously is a problem because it lowers the overall sample size, which, obviously more participants usually helps. And so lowering that sample size is can be a problem. And also this is that volunteer bias that we talked about way back at the beginning of the textbook. I think it was chapter 3, maybe it's one of the first few chapters that we talked about volunteer bias, where the people that you're left with are the people that were more motivated to stay into the study or more likely to volunteer for things like this. And so that limits your external validity, because you're not able to generalize your results to the population at large, because not all of those people are volunteer type people or people that are motivated like this to stay in a study. And so depending on what your variables are, that can affect whether you're able to generalize this to a larger population if you have a lot of people drop out, if that attrition rate is high. So how do we choose between the two? Well, basically you can see that the advantages of the within and between subject designs are essentially the same as the disadvantages of the other. They just flip back and forth, right? So the three main factors here to consider are, the first is individual differences. Remember, between subjects designs, this is a problem. The individual differences creates that static. We're not able to see. It can affect the internal validity and create confounds that we aren't able to see the differences that we want to see in the dependent variable. Within subjects eliminates these individual differences. So if you are concerned with your type of study, with your variables you're studying, if you think that there's going to be large individual differences between your subjects for whatever reason, then it is a better idea to use a within subjects design for that particular study, right? The second variable, or the second factor here to consider, is time-related factors and order effects. So again, between subjects design eliminates those, whereas within subjects, that is an issue. So if you are expecting there to be time-related issues or order effects, if you think that if you are that something in your second and third treatments, if those are going to be affected over time, if it's going to affect those future conditions for whatever reason, if you're concerned about those kinds of confounding variables, then you should use a between subjects design instead, right? Because that would eliminate those time-related factors or order effects. And then lastly, this isn't as quite as big of a consideration, but again, fewer participants. So if you need larger participants for whatever reason, then you're going to have to use a between subjects design. Yes, that's true, but you could also use a within subjects design with large amount of participants. But if you need to use fewer participants for whatever reason, then that within subjects design is going to be your better choice, because it is just not going to be as possible to do between subjects designs with less participants. So with a matched subjects design, that is something that is kind of combining the two, the two different, or the advantages of the within subject and between subjects designs, and trying to negate the disadvantages. And so it kind of combines the two. So what happens is you use a separate group of participants for each treatment condition, just like a between subjects design, but each individual in one group is matched with an individual on the other group on a certain variable, so that it's like they're the same person, even though they're really not. And so it has to be a variable that is particularly relevant, like it said, to your study. So the example your book uses is a study on math achievement scores. They want to see what teaching method helps improve math achievement scores the most, right, or is the most beneficial. So what you would do is you would first do a math achievement test on the students to see where their math achievement lies currently, their math abilities lie currently. And you would, let's say Bill and Joe scored the same amount. They had the same score. Then you would put Bill in one group and Joe in the other group. You would match them. They would be a pair, right? And then say Selena and Brittany scored the same, and so you would put Selena in one group and Brittany in the other. And so the one group of the pairs will experience the one teaching method, and then the other group will experience the other method, and then you will compare to see the difference, and see which teaching method works the best. So it helps minimize those individual differences between the subjects. The goal is to duplicate the advantages and not having the disadvantages of each one. So again, the between subjects concern is the individual differences. So it helps minimize that, but it also but the downside to within subjects is the order effects. But you don't have to worry about that, because there's different participants in each group, right? Now, it doesn't completely eliminate the individual differences like a within subjects design, because even though they're matched on that variable, that doesn't mean they're completely similar. They're still not exactly the same person, right, on all variables. And so it does reduce those individual differences, but again, it's more of an in-between. It is in between the within and between subjects advantages and disadvantages, because again, it can't completely remove those individual differences. And it is also possible to use more than one variable. So in the example, we matched the math achievement scores. That was the variable we matched them on, or we paired them on. You can use multiple variables. So you could actually pair someone on gender, age, and IQ if you wanted to. But that gets a lot more complicated, obviously, and a lot more difficult, because it's going to be hard to find a female who's 28 years old whose IQ is 118 with another female who is 28 years old who has an IQ of 118. When you have more variables, when you have 3 variables instead of 1 there, that obviously makes it a lot more complicated, a lot more difficult. But it just depends on what variables are relevant to your design, right? Okay, so knowledge check. What are the 2 disadvantages of a within subjects design? And hopefully, we've just talked about that. The two disadvantages are the time-related factors, all of those things we talked about, the history, effect, maturation, instrumentation, um, order effects, and then also um, participant attrition, them just simply dropping out because they're being measured a lot or it's overtime and they just end up not completing the study. Here's our learning check from our chapter. What is measured and removed to reduce the variance in within subjects design compared to between subjects design? So remember, what is being removed is those individual differences, right? The between subject design, that's what the concern is. Within subjects, you can eliminate the individual differences and you can also remove and reduce it as well. And we talked about that in those tables and those graphs. Which of the following is an advantage of the between subjects design versus within subjects? So what does between subjects have that within subjects does not? And hopefully you will realize that that's the risk of order effects. That's the concern within subjects. So the between subjects design eliminates that. There are no order effects because there are different participants in each condition. And then for an experiment that compares two treatment conditions with 10 scores in each treatment, which design would require fewer subjects? And this one's kind of a little sneaky, little trick question because a within subject design is always going to require the least amount of subjects, right? And so it doesn't really matter if there's 2, 3, 4, whatever treatment conditions, and it doesn't really matter if there's 10 scores or 15 or 20 scores. In general, no matter what, within subject design, it's going to have fewer subjects just because it's the same subjects being tested in each condition, right? So hopefully you guys are helped by these PowerPoint videos. And so that is all for section 9.3.